Right, so what we need to look at now is how is electricity generated. Okay, so when we're talking about generators in a power station, what is happening? When we're talking about generators in general, what is happening? Where does it come from? The title of this is Induced Potential. Potential refers to voltage, induced refers to made or created. It's not really a synonym for made or created, but that's the gist. So key concepts we need to deliver before this topic can make sense. We need to define voltage, also known as a potential difference. Potential difference is what it's called on the AQA exams, even though either example or either word is accepted. So potential difference is the amount of energy per charge. Okay, so if we think about it, of a wire with the electrons in it connected to a battery with a positive and negative terminal. For those pendants out there, that's a cell, not a battery. Okay, then what's happening is the voltage, the potential difference, is supplying energy to each electron that exists in the wire. Current is once you have had that energy applied, the electrons will move around the circuit. Something to point out is electrons will move around the circuit. Conventional current acts in the opposite direction. And this is because when the person came up with conventional current, he had to pick a direction. He picked the direction of conventional current, and it just turned out that the electrons weren't moving in the same direction. We're going to have to get over that, unfortunately. The last case concept related to induced potential is the motor effect. So here, using Fleming's left-hand rule, we've got the current moving from right to left. We've got the magnetic field coming out of the page. So Fleming's left-hand rule, field and current are going that way, so therefore the wire kicks upwards. Let's imagine that we've got an electron gun. Okay, so thermionic emission, stimulating a wire or a cathode to something that's so hot that it starts releasing electrons. If we fire the electrons into the magnetic field, when it hits the magnetic field, it will curve. And that's because of the perpendicular force that's acting on it. So here, the field is going into the board, the electron is moving left to right, which means the current is moving in that way, so the electron curves downwards. So that's what would happen if we fired an electron into a magnetic field. Now let's say that we've gripped a wire. So let's say we grip a wire with electrons in it. Okay, so we hold it tight and we move that across a magnetic field that's going into the board. Now, the electrons are confined to the wire, but they will move in the same direction as if they were just lone electrons being fired into the electromagnetic field. So this electron will curve downwards, this electron will curve downwards, and this electron will curve downwards as we move the wire across the magnetic field. Because these electrons have moved downwards, we've got a positive region at the top, because the electrons have all moved downwards out the way. Because this has now got a gain of electrons, this area is negative. So it acts in the same way as a cell. What happens is, we've got a positive area and a negative area. And just like our cell, we've got a positive and negative terminal, therefore we're making a potential difference. And it's that potential difference that causes the electrons to move. So in a power station, what you've got is you've got a wire moving around in a circle in a magnetic field, and every time that's happening, we are creating a positive and negative terminal, and that's why the potential difference is created. And if it's part of a complete circuit, that's why we get current. So when you get mains electricity, that is what's going on in the power station. Key points, the wire needs to be moving. If you move it into a magnetic field and stop, the electrons will go back to their original position, and then your current will stop eventually. So, if you were given a 4-mark question on this, your response would be thus. You need to get a wire to cut across a magnetic field line, or cut through a magnetic field line. Once you've done that, the voltage is induced across the ends of the wire, which is what's going on in the top right. Only if the circuit is complete will a current flow around the circuit. This is known as the generator effect, and this is how potential difference is induced. Okay, in terms of what's going on at the top here, that is an A-level explanation. However, I think it helps it make sense. If we look at the alternative, where we're moving a magnet into a coil of wire, instead, that works in the same way. Magnet goes into the coil, and we generate a current, which is represented by the needle deflecting. If the magnet is stationary inside of the coil of wire, then we have no current being created because it's not moving. If we move the magnet back out in the other direction, then we have a current in the other direction. Look at the board, take your time to read through it. If you don't get it, these are the key points that you need to understand. Thank you.